Coastal cities worldwide face unprecedented challenges from a confluence of climate change impacts and complex socio-economic shifts. This new reality renders traditional, linear planning methods, which often rely on historical trends and singular forecasts, inadequate for the task ahead. To build resilience in this era of uncertainty, urban planning must pivot towards methodologies that embrace complexity and make plausible futures discussable and negotiable among those who will inhabit them. Scenario design and stakeholder communication emerge as two intertwined, critical disciplines in this modern approach. Scenarios provide a structured way to explore a range of possible futures, while robust communication and participatory co-creation ensure that the resulting strategies are relevant, equitable, and actionable. Learning objectives. The strategic value of scenario planning for coastal communities. Scenarios as structured explorations of plausible futures. Types of scenarios. Turning uncertainty into adaptive planning. Scenario design framework. Communicating complexity. Narrative and storytelling. Scenario visualization techniques. Tools in scenario shaping communication techniques. Participatory and gamified communication. Principles of stakeholder engagement. Creating equitable and trust-based engagement processes. Engagement formats. Collaborative scenario building techniques. Smart technologies and simulation for scenario development. Pillars of resilience for coastal scenario development. Digital resilience for coastal scenario development. Summary and reflections. Understand the value of scenario design in resilience planning for coastal cities. Learn techniques for communicating uncertainty to diverse stakeholders. Explore visual, participatory, and narrative-based approaches to enhance engagement and decision-making. The strengthening of adaptive capacities in coastal urban environments has become imperative in the context of the global climate crisis. With nearly 40% of the global population living within 100 kilometers of a coastline, these areas are critical hotspots due to their particular vulnerability to climate change. This high concentration of people and infrastructure necessitates the development of holistic strategies that are durable and effective over time, particularly to benefit the most at-risk communities. Coastal cities face a host of complex and interconnected risks that are intensifying due to global warming and direct human impacts. The most common threats include sea level rise, increased intense precipitation, more frequent heat waves, greater intensity of tropical cyclones, and more extreme droughts. These challenges are compounded by urbanization, which often makes coastal ecosystems less resilient. The combined effects of climate change can significantly influence severe weather events, impacting not only coastal urban areas but also adjacent inland cities, demonstrating the inevitable interconnection of the climate crisis consequences across geographies. To navigate this uncertainty, there is a clear need for adaptive, forward-looking participatory planning methodologies. By developing scenarios for hazards, risks, and opportunities, stakeholders can collaboratively create action plans that manage risk, capitalize on opportunities, and increase resilience in the face of an unpredictable future. Scenario design is a structured process for generating narratives of plausible futures. Its function is not prediction, but to make complexity and uncertainty planning resources that can be used to test strategies, stimulate innovation, and create an easy-to-read visualization of the plausible futures for stakeholder deliberation. It is an interdisciplinary approach that integrates scientific knowledge of landscape and climate change with the practical, context-specific knowledge of local stakeholders, making the abstract concept of the future tangible and debatable. A scenario typology helps structure thinking about the future, especially under conditions of complexity and uncertainty such as climate change adaptation, disaster management, and urban planning. Scenarios are not forecasts. Rather, they are coherent and plausible stories about how the future might unfold. They are commonly classified according to their primary purpose, with the main types being exploratory, normative, and strategic scenarios. Each serves a distinct but complementary purpose in the planning cycle. Exploratory scenarios. This approach explores what might happen to a city or landscape. It generates narratives of plausible future trajectories based on key drivers and uncertainties. The aim is to understand the range of potential outcomes and prepare for various contingencies, enhancing the robustness of plans. Normative scenarios. This approach asks, what should happen, and identifies specific strategies needed to reach a desired future goal. It is inherently goal-oriented. A key technique is backcasting, which works backward from a shared, desirable future vision to identify the necessary interim goals and present-day actions to achieve it. Strategic scenarios serve as a bridge between exploring future possibilities and making concrete decisions in the present. Their purpose is to directly support planning by linking potential future developments with immediate choices. Strategic scenarios help decision-makers test the robustness of their strategies against multiple potential futures and select the most resilient combination of actions. They translate uncertainty into practical guidance, enabling communities and organizations to prepare risk management strategies and take advantage of emerging opportunities. Embracing uncertainty transforms it from a barrier into a crucial input for robust, adaptive planning. This approach reframes uncertainty not as ignorance or a lack of data, but as actionable information that is more useful for strategic decision-making than having no information at all. By exploring extreme, wildcard events and conducting sensitivity analyses on complex systems, planners can move beyond rigid, singular solutions. This necessitates a shift towards fostering flexibility and adaptability, building the capacity of communities and systems to continuously adjust their strategies in response to new information and changing circumstances, thereby avoiding the pitfalls of static, one-size-fits-all interventions. The value of resilience planning is clearly demonstrated through scenarios, which serve as diagnostic and strategic tools. By constructing coherent narratives of plausible futures, this process exposes hidden vulnerabilities and uncovers opportunities within complex urban and social ecological systems. Furthermore, resilience planning encourages long-term, cross-sectoral thinking essential for addressing challenges like climate change. This collaborative framework, bringing together government agencies, the private sector, scientists, and civil society, fosters shared understanding of risks and common purpose. Such transdisciplinary engagement is critical for producing holistic, equitable, and sustainable adaptation strategies that are scientifically grounded, politically feasible, and socially accepted, ensuring they remain robust in an uncertain future. The scenario design framework begins with identifying the key drivers of change that shape a city's future. Factors such as climate trends, demographic shifts, technological innovation, governance quality, and economic forces. This step expands the planning horizon by mapping broad social, environmental, and infrastructural forces that interact in complex ways. When planners articulate these drivers early, they can better understand which elements of the urban system are stable, which are volatile, and which require close monitoring in long-term resilience planning. Because not all drivers influence the future equally, the next step is to prioritize critical uncertainties. These uncertainties, such as future rainfall patterns, migration flows, energy affordability, or political stability, are the dimensions where outcomes cannot be confidently predicted yet will profoundly affect urban resilience. Plotting these uncertainties into matrices or cross-impact maps helps planners visualize different directions the future might take. This prioritization shapes the scenario space, ensuring that the resulting futures are meaningfully distinct rather than small variations of the same assumption. Once drivers and uncertainties are clarified, planners can build scenario narratives that describe plausible future conditions and then test strategies across these scenarios. Narrative scenarios give life to the analysis, making future worlds understandable to diverse stakeholders by blending data with human context. Testing strategies against all scenarios, rather than a single expected future, reveals which policies, infrastructure choices, or adaptation pathways remain robust even when conditions shift. This iterative evaluation strengthens decision-making and supports long-term resilience, helping cities avoid rigid plans and instead adopt flexible, adaptive strategies suited to a world of accelerating change. Communicating complexity in resilience planning means making difficult information understandable to diverse audiences who perceive risk in different ways. While technical experts may focus on probabilities and models, community members often interpret risks through lived experience, emotions, and cultural context. Effective communication must bridge these differences. To do this well, planners need to combine clarity, empathy, and evidence. Clarity ensures that information is accessible, empathy acknowledges people's concerns and perspectives, and evidence maintains scientific credibility. Together, these elements create messages that resonate both intellectually and emotionally. Visualizing trade-offs and interdependencies, such as how flood protection affects land use, or how heat mitigation impacts energy demand, helps audiences see the bigger picture. Visual tools transform abstract data into intuitive insights, enabling stakeholders to understand the consequences of choices and to participate more meaningfully in decisions. Narratives humanize data by connecting abstract information to lived experience, emotion, and cultural meaning. When complex evidence is framed through shared values such as fairness, responsibility, and protection, it becomes more relatable and easier to act upon. Story-based scenarios, with identifiable people, places, and everyday situations, enable planners and communities to better imagine future conditions and understand how risks may shape real lives. This approach transforms technical analysis into meaningful insight rather than distant statistics. The idea of resilience imaginaries builds on this narrative strength, using storytelling to legitimize adaptation and planning efforts in uncertain contexts. By turning abstract climate risks into tangible social visions, scenarios provide direction for strategic decision-making. Practical tools such as personas or a day in the life narratives anchor complex models in human realities, integrating scientific knowledge with local experience to ensure that planning processes remain credible, inclusive, and socially grounded. Scenario visualization techniques translate complex future conditions into formats people can easily grasp. Maps and 3D models help stakeholders see spatial patterns and physical impacts within a city, while interactive dashboards allow users to explore different assumptions, timelines, or risk levels. Dynamic infographics provide real-time or frequently updated visuals that highlight changing trends, making scenario information more engaging, accessible, and actionable for diverse audiences. Tools used in scenario shaping help translate complex futures into formats that stakeholders can understand and engage with. Visual tools such as story maps and dashboards simplify large datasets and make patterns, risks, and opportunities immediately visible. These tools are especially effective for highlighting spatial relationships or showing changes over time. Participatory methods like workshops and focus groups bring stakeholders directly into the process, allowing them to voice local knowledge, negotiate trade-offs, and build ownership over scenario outcomes. This collaborative involvement strengthens the legitimacy of planning decisions and ensures that diverse perspectives shape future visions. Narrative and digital tools expand the imaginative and experiential dimensions of scenario work. Future stories help people emotionally connect with possible worlds, while simulations and games allow stakeholders to interact with scenarios dynamically. Together, these tools make complex planning processes more accessible, engaging, and meaningful for different audiences. Communication techniques make future scenarios understandable and relatable by presenting complex information in accessible formats. Story maps combine spatial data with narrative elements, helping audiences explore how different futures unfold across specific locations. Dynamic dashboards add interactivity by visualizing real-time or adjustable data, allowing users to compare scenario outcomes and experiment with assumptions. Simulations and 3D environments take engagement a step further by enabling stakeholders to virtually walk through possible futures, experiencing changes in infrastructure, climate impacts, or neighborhood conditions. These immersive tools make abstract futures tangible and can significantly improve public understanding and policy dialogue. Infographics and comics simplify complex ideas for broad audiences, translating data-heavy or technical scenarios into clear, memorable visuals. Together, these communication techniques make scenario information more transparent, engaging, and useful for decision-making across diverse communities. Serious games and simulation games are viewed as effective instruments of participatory modeling. Gamification of the urban planning process can enhance public participation and help participants better understand complex problems due to the interactive environment provided by the game platform. Serious games are powerful communication tools, particularly in disaster risk management, as they foster risk awareness, perspective taking, and empathy. These tools aim to provide an immersive experience essential for facilitating multi-stakeholder interaction. The design of serious games for resilience planning frequently incorporates key elements such as role-playing, physical elements, e.g., tokens, dice, boards, tabletops, digital support, e.g., dashboards for real-time visualization of decisions. Simulations often use hypothetical scenarios, like flood scenarios due to sea level rise, using a model that allows participants to understand the system while interacting in a user-friendly platform. Such games structure communication in complex socio-technical systems, STSs, and can transform difficult conversations into simulations of decision-making negotiations in a safe, experiential environment. Effective stakeholder engagement is built on principles that ensure the process is fair, meaningful, and trusted. Inclusion means bringing marginalized or less heard voices into the conversation so that scenarios reflect the full diversity of community experience. Empathy allows planners to understand how different groups perceive risk and imagine the future, creating space for emotional as well as technical perspectives. Transparency strengthens trust by openly communicating both evidence and uncertainty, avoiding hidden assumptions or selective information. Ultimately, legitimacy comes from co-developing the process with stakeholders, not just presenting outcomes, so that decisions are grounded in shared understanding and collective ownership. Effective adaptation in coastal zones demands local-level action informed by accurate data, a long-term vision, and broad collaboration. An inclusive, participatory process that involves government agencies, the scientific community, the private sector, and civil society is essential for developing robust and equitable solutions. Cities that adopt co-design and co-implementation approaches with local communities achieve greater public acceptance and support for adaptation measures. This collaborative governance is fundamental to addressing complex issues like climate justice, ensuring that solutions are appropriate to the local context, strengthen social cohesion, and prevent the further marginalization of vulnerable populations. Engagement formats offer different ways for stakeholders to participate in shaping future scenarios, ranging from creative exploration to structured analysis. Co-design workshops are hands-on sessions where local communities collaboratively generate scenario ideas using tools like sticky notes or online whiteboards. Multi-stakeholder panels serve a more formal purpose, bringing together policymakers, industry representatives, and experts to build consensus through guided roundtable discussions. Visioning sessions encourage students, NGOs, and community groups to imagine future possibilities using visualization tools, opening space for creativity and aspirational thinking. Backcasting, in contrast, is suited to technical planners who use system mapping software to work backward from a preferred future and outline the steps needed to reach it. Together, these formats bridge imaginative engagement with pragmatic decision-making, ensuring that diverse voices and modes of thinking inform scenario development. Collaborative scenario building techniques bring stakeholders together to co-create future pathways using diverse forms of engagement. Backcasting begins with a desirable 2050 vision and works backward to identify the steps, policies, and partnerships needed to reach it. Participatory mapping overlays local knowledge onto digital or physical maps, helping communities visualize risks, resources, and priorities in place-based ways. Deliberative dialogues provide structured forums for discussing trade-offs and resolving conflicting values, ensuring decisions are fair and transparent. Scenario prototyping turns ideas into tangible models or mock-ups, enabling stakeholders to interact with potential futures and refine them collectively. Together, these methods deepen understanding, broaden participation, and strengthen the legitimacy of scenario outcomes. Advanced simulation technologies are transforming environmental planning and disaster management by enabling dynamic scenario analysis instead of static assessments. Artificial intelligence, AI, machine learning, ML, and deep learning, DL, models process vast datasets to predict spatiotemporal flood patterns and generate innovative mitigation strategies. Their capabilities are realized through digital twin systems, which use integrated tools, such as GIS-based urban climatic maps, remote sensing, computational fluid dynamics, CFD, and socio-hydrological models, to design climate-resilient infrastructure and test policies or evacuation plans in simulated environments. The value of these scenarios is enhanced by digital visualization technologies, including 3D web tools, augmented reality, AR, and virtual reality, VR, which turn complex data into interactive and accessible representations. By supporting participatory processes like participatory scenario planning, these tools combine scientific and local knowledge, foster shared understanding, and build trust for effective climate adaptation. Digital resilience in coastal planning rests on a multi-layered foundation that keeps data, systems, and institutions reliable under stress. Data integrity and governance ensure trustworthy scenarios, while infrastructure reliability keeps digital networks and monitoring systems functioning during extreme events. Adaptive modeling enables real-time updates as new climate data emerge, supported by cybersecurity and risk management that protect against disruptions and digital threats. At the institutional level, inclusive access allows communities and experts to engage with scenario tools, strengthening shared understanding and legitimacy. Institutional continuity sustains stable governance and knowledge over time. Together, these layers create coastal scenarios that are scientifically sound, socially legitimate, and operationally resilient. As climate risks intensify, scenario development will increasingly depend on digital systems. Cities that invest in digital resilience will be able to anticipate complex hazard interactions, create more realistic adaptation pathways, engage communities effectively, ensure continuity of governance under crisis, and make long-term, evidence-based decisions. Digital resilience is no longer optional, it is a foundation for climate-resilient coastal futures. Scenarios make the future discussable and negotiable. They are powerful planning tools that transform uncertainty from a barrier into a resource for building robust, flexible strategies for coastal resilience. Effective communication requires both tools and empathy. Success depends on combining advanced visualization and modeling tools with participatory processes that build trust, foster social learning, and respect diverse forms of knowledge. Co-produced narratives enhance resilience, legitimacy, and action. A collaborative approach ensures that planning outcomes are not only technically sound